So in section 5.5, we are factoring trinomials. We have learned in the past how to factor just any polynomial by finding the GCF. We learned how to factor polynomials by grouping. We learned about some special cases. Yesterday we looked at factoring trinomials, but all of the trinomials we looked at yesterday had 1 as the A number. All trinomials are in this form here, ax squared plus bx plus c, where the first term has x to the squared, the second term is just a plain x, and the last term is a plain number. But all of the problems we saw yesterday, all of these numbers here were all 1s, making these factoring problems a little bit easier. Today, we are going to be seeing problems where this first number is not 1. So if you look at this first example here, there's a 3 here, there's a 4 here. So when this happens, the process just changes a little bit and it becomes a little bit more complicated. So make sure we're looking at the differences and similarities between yesterday's lesson and today's so you can kind of understand what's going on. So in example 2, we're factoring trinomials where the first number is not equal to 1. Letter A is actually an interesting problem because it's under the factoring trinomial section, and yet it's not a trinomial. A trinomial means 3 terms. This term actually doesn't have the middle term here. Usually they're in this form, ax squared plus bx plus c. Letter A is missing the middle term, the plain x number. So this is going to be an interesting problem. Let's see what happens. The first thing you should always do when you see a problem that you have to factor is look for a GCF. So look at all of the terms and see, can you pull anything out of everything? So I don't really know. Let me just try. I see there's a 3 here and a 108. Let's see if 108 is divisible by 3. I'm going to do 108 divided by 3, and it is. 36 times 3 is 108. So what I'm going to do is pull out a factor of 3 from both terms. Once I take that GCF out, then I can actually see better what's going on here. And this is something that is going to be a little bit confusing until you get the hang of it through like a bunch of practice problems. This is considered a special case. If you remember when we did these problems last week, this is a perfect square and this is a perfect square. X squared is x times x, making it a perfect square, and 36, 6 times 6 is 36. Both of these numbers are perfect squares, meaning that this is considered a difference of squares problem, and this can be factored. When I factor this is essentially x squared plus 0x minus 36. The middle term is not there, which means that when I go to factor this, I'm looking for the factors of 36, or negative 36, that multiply to be negative 36, but at the same time add to be 0. So if we're thinking about the factors of 36, and we just start writing them all out, 1 and 36, all right, 2 and 18, 3 and 12, 4 and 9, 6 and 6, I'm looking for these two factors to multiply to be negative 36. So I would have to have one positive and one negative. And those same two factors that multiply to be negative 36 have to also add to be nothing. What two factors would be able to do that? Yep, the 6 and the 6. So in order to factor this, you can think about it as the middle term being 0. One of these 6's has to be negative, the other has to be positive. And then I will have this factored as 3 times x plus 6 times x minus 6, or in any order, the x minus 6 could be first and the x plus 6 could be second. I just usually just put the plus first. I don't know why. So x squared minus 36 is factored as x plus 6 times x minus 6. Now, we actually learned this last week, and during that section with those examples, I didn't even show you this process yet with all of this factoring over here. I just showed you that if you have a perfect square here and a perfect square here, take the square root of this. What number times itself equals 36, which is 6 and 6. Make one of them positive, one of them negative, put them in this form, and you have it. This is considered the completely factored answer to this problem. This is how you would want to leave your answer as 3 times x plus 6 times x minus 6. All right, looking at letter B, we're going to be doing the same exact thing in letter B. First, you're trying to figure out, okay, can this thing be factored out? Can I take any numbers or variables out of all 3 terms? So I'm looking 4x to the third, 32x squared, and 64x. I can take a number and a variable out of all three of these terms. What number can I pull out of all three numbers, the largest? 4, yep. And how many x's can I take out of all? Yes, just one x. So I can take the GCF 4x out of everything. When I do that, I would have to have x squared left over so that it still will equal 4x to the third power. And then minus, if I take a 4 out of 32, I'm going to have 8. If I take 1x out of x squared, I'll have 1x left. And then if I take a 4x out of 64, I'm going to have 16. And I'm taking all of the x's out, so it will just be that. Now, when you take out a GCF, that does help you factor the problem, but this is not the final answer anymore. When we first learned GCF, if I gave you a problem like this, you would have just been done at this point and just circled your answer and it would be factored. But this is not factored completely. Factoring something completely means that every single part has no common factors. Now, right now, if you look at x squared, negative 8x, and 16, there's no other common GCF factors I can take out. That's true. But we now did learn that there is a new way to factor these types of problems, these trinomials that look like this, that have an x squared, a number of x's in the middle, and then a number at the end. And what we did, the process we learned, was that we look at the number here, which is the a number, the number in front of x, in this case is 1, and we look at the last number here, 16. We multiply these two numbers together, the a number and the c number. 1 times 16 is 16. So we're trying to find the factors of 16 that add to be the middle number. And the middle number, the b number, is negative 8. So what I know is that in order to multiply to be a positive number, and at the same time add to be negative numbers, those two factors need to be negative. So when I go to list the factors of 16, 1 and 16, 2 and 8, and 4 and 4, I know that these all will have to be negative in order to be able to multiply to be a positive and add to be a negative. So now I'm going to think of all of these factors as the negative versions of themselves. So like negative 1 and negative 16. Negative 1 times negative 16 is positive 16, but negative 1 plus negative 16 does not equal the negative 8. Negative 2 times negative 8 is positive 16, but negative 2 plus negative 8 does not equal the middle number, which we need to be negative 8. So it's not that one, it's these pairs here. So the negative 4 and negative 4. And that's because negative 4 times negative 4 is positive 16, and negative 4 plus negative 4 equals that negative 8 that we needed today. So what that means is when I go to factor this completely, I can factor this trinomial as x minus 4 times x minus 4 like that. Okay, so this would be 4x times x minus 4 times x minus 4. That would be the final answer. You could also write it this way, 4x times x minus 4 to the power of 2. And that's because the x minus 4 is being repeated, so you can simplify it further by just like writing it like that. It's correct either way. I would accept either answer. And maybe pre-calculus, your teachers would want you to answer it this way. But for now, it's okay if you leave it like that. So that's how you would factor out a GCF and then factor completely. Looking at the second letter B down here, I'm looking at 4x squared plus 5x minus 6. And just by quickly seeing that, I don't see anything I can take out of all three terms. So when you're stuck here and you have a trinomial and there's nothing to take out, then there's a new process that we have to use to find the factored version of this. Sometimes these cannot be factored, in which there will be a different method to do it. But for now, all of these can be factored. What we need to do now that this first number is not equal to 1, and I can't take a GCF out to turn it into 1, because if you look at this example, I took the 3 out, and I was left with 1x squared here, which makes it easy. I took the 4 out and the x, and then made this 1x squared, which then makes it easy. This 4 cannot be factored out, so what I have to do here is now work with the 4 number and this number. When I multiply a times c, the a number is 4, and the c number is negative 6. A times c, 4 times negative 6 is negative 24. All right, so that is going to be the number I'm trying to multiply to get. And at the same time, those factors that multiply to be negative 24 have to add to be the middle number, which is 5. Okay, so it has to add to be 5, which is the middle number, and multiply to be negative 24. So what we're going to do is the same process as before. Let's list all of the factors of 24. Let's pretend it's positive for now, so we can just list them, and then think about what would happen in order for it to be multiplied to be a negative. So the factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. In order to multiply to be a negative number, you have to have one positive factor and one negative factor. So think about these numbers and one being positive, one being negative. You need to somehow get these two factors to equal a 5 by having one positive and one negative. So I'm looking at the 1 and 24. If the 1 was negative, negative 1 plus 24 is 23. And the opposite would just end up being a negative 23. So it's not those, they're too far away from each other. The 2 and the 12 are too far away from each other too, because if you have a negative 2 and a positive 12, that would give you 10. Vice versa, if it was a positive 2 and negative 12, it'd give you a negative 10, so that's not it. But the 3 and the 8 are going to work. They're 5 away from each other, so if I use subtraction or if I use one number being negative, I can get a positive 5 from that. You have to choose the correct one, though. Which one would be negative? The 3, yeah. So this would be a negative, since negative 3 plus 8 is 5. Now, here's what's very interesting about this process. This is a little bit different than before. Before, once you picked your factors, like once we picked the factors here, I could go ahead and just go ahead and put it into the factored form and be done with it. When this number is not equal to 1, this is going to be a longer process. When we go to write out the factored form, we actually can't just factor it from here. What you have to do is take the original problem, 4x squared, and the plus 5x, I'm actually rewriting as the factors that create 5x when you add them. So what I'm doing is actually writing out the 5x as the sum of negative 3x plus 8x minus 6. Now bear with me. What I did here was I took these two factors and I added x's to them because I know negative 3x plus 8x equals the 5x here. When you have a number that's not equal to 1, when this number is not equal to 1, it's a kind of a different process. Instead of being able to just factor it, you actually have to take this middle number that these factors should add to be and expand it into those two factors with the x's. Now, negative 3x plus 8x does equal 5x, but this is what we have to do in order to factor it this way. Now, there are other ways to do this. There are tricks that I've learned along the way, and by learn, I don't really understand it, but this is the way I learned in the very beginning, and sometimes with math, once you learn it one way, there is no other way. That's how my brain works, but I can help you if you don't understand this after we try it a few times. So, once you have 4 terms, we already learned how to factor 4-term polynomials by grouping. You draw a line through the center here, and you factor each part separately using the GCF method. So 4x squared minus 3x. The only thing they share is a factor of x. So I'm going to take a factor of x out of each part here, and it's going to be left with 4x minus 3. And then on the right-hand side, 8x minus 6. They only share a factor of 2, so I'm going to take a positive 2 out, and I'm left with 4x minus 3. If you do this correctly, you will see this exact thing happen both times, that the inside, what's in the parentheses will always match. It's like magic. I don't know how it works, but it does. And then once you have that happen, then you can put it all together in its factored form. The factored form would be 4x minus 3 times this stuff here. So this is going to be an x plus 2. So this together can be in a separate parenthesis set. Or you can switch the order, and it could be x plus 2 times 4x minus 3. It's up to you. I usually write the x plus 2 first, and then the 4x minus 3 second. It doesn't matter. So this process is weird. What we did was we had to multiply the first term by the last term to get the fancy number we're looking to find the factors of. That was negative 24. We listed all of the factors here. We found the lucky pair that does exactly what we need it to be, which it means that it multiplies to be that number and at the same time adds to be the middle number. But instead of being able to factor it from there and be done with it, this process takes a little bit longer because the original A number is not 1. So you have to split up the problem and make the trinomial into a polynomial with 4 terms by taking this middle term and expanding it into the 2 factors that add to be it. So you're making it longer so that you can factor it by grouping. Once you factor it by grouping, then you should see the same thing happen and in the parentheses, and then you have your factored form. Remember, you can always check your answers by multiplying things out, and you can verify that this is correct. All right, so if we flip over to the next page, I want you guys to try one on your own. I can help you out with the steps, but we'll try C first. The first thing you should do when you see a problem that's a trinomial is look for a GCF. 2x squared minus x minus 21. There is no GCF. There's nothing you can take out of all 3 of those terms. So once you're done with that, the next thing you should do is look at the A number and the C number and multiply those 2 numbers. So I mean multiply 2 times negative 21. Once you get that number, that's what you're trying to multiply to be, but at the same time add to be the middle number. So I'll start this off for you and then hopefully you can finish it out. 2 times negative 21 is negative 42. So we're looking to multiply to be negative 42. And at the same time, we have to add to be a negative 1. Because that's what the middle term is. The B number is going to be negative 1. So we're looking to multiply to get negative 42 and add to be negative 1. So what you should do now is list the factors of 42. 1 and 42. 2 and what? What and what? And then because it's a negative 42, you're trying to multiply to be, one of those factors will be positive and one will be negative, and they should add to be a negative 1. Once you get that part, then let's see if you remember how to split it up and factor by grouping. I'll give you a couple minutes to get started. If you're really struggling, then you just try your best, and then I'll go over it in a few. Once you have 2 lucky pairs, which is right, 6 and negative 7, you take this thing, and you're going to rewrite negative 1x as these 2 pairs that you have here. 2x squared plus 6x minus 7x minus 21. And that always is the same no matter what. So if we did it for this problem, it would be 3x squared. So if we did it for this problem, it would be 3x squared, and then it's going to be this negative 16x. It's going to be broken up into 2 x's that combine to be that. Okay. Okay, so that's what you do next. And then once you do that, you separate it down the middle, and you factor it separately. Yeah, so 2x squared plus 6x. They share a common factor of 2 and an x. So I can take a 2x from both terms. So then you put in a parenthesis here. And then 2x times x is 2x squared, so we have an x here. And then plus 2x times 3 is 6x. So the 3 is there. And then for the right-hand side, we're going to be factoring a negative 7x minus 21. Now, what's odd about this is whenever this number here is negative, whenever this number starts with a negative, you have to take a negative factor out. So 7x do that. Negative 7 times x is negative 7x. And then in order for this one to multiply to be a positive 21, this would be a plus 3 here. Since negative 7 times 3 is negative 21. Okay? And then you will always see this happen. Same thing will be here and here. Always. So when you have that, you should know, okay, I did it right. When you have this here and here, it's the same thing always. So then what you do is you rewrite it with a 2x and a minus 7. That goes into one separate parentheses. Wait, you rewrite it? Mm-hmm. You take the 2x and then minus 7 and put that in its own separate parentheses and multiply that by the other one, x plus 3, and that's your final answer. Okay, I think I found that. Yeah, I know. It's weird. All right, so let's go over C together, see how you made out with this one. So the whole idea here with this type of factoring is undoing the foiling process. And if you remember, every single time you FOIL a binomial times a binomial, you get 4 terms. So in order to factor a trinomial that is simplified down to be 3 terms, we have to figure out what the 4 terms were going to be before you add the middle 2 numbers together. So the process says take the first number, the A number, and multiply by the last number, the C number. Get that number. That's the factors that you need to list. So like the factors of 42, I'll pretend it's positive for right now. 1 and 42, 2 and 21, and then 3 and 7, and, oh wait, what am I doing? I'm doing 21, sorry. 3, and I don't think there's anything 3, but I know it's 6 and 7, so I'm just going to write 6 and 7 here. And I know that these numbers have to multiply to be a negative 42, so that means one would be positive, one would be negative. If I make this a negative 1 plus 42 is only going to be 41, and vice versa, it'll be negative 41, so it's not this pair. It's not going to be this pair either because they're too far away. Negative 2 plus 21 is not going to be negative 1. I'm going to be able to get a negative 1 from a 6 and a 7 through adding them if one of them is negative. So then you have to choose the correct negative. If it's a negative 6 plus 7 would equal a positive 1. We need the opposite. We need it to add to be negative 1, so the 7 would have to be negative because that's the larger number. So if you make that negative, the answer is going to be negative. So what's weird about this problem is usually you'd be able to just factor it from here, but what you're really doing is this is really representing a 6x and this is really representing a negative 7x. And what you're doing is taking this original problem, 2x squared minus x minus 21, and you're rewriting it using these factors you just found. So you're taking the trinomial and you're expanding it into the 4-term polynomial that it is when you FOIL it out. Because every time you FOIL first, outer, inner, last, you get 4 terms. And now we have found what those 4 terms are when I go to multiply it out if I was thinking about it in the opposite direction. Once you have 4 terms, then you can factor by grouping, which means you take a line and you just draw it down the center after that second x, or the first x here, and you factor each side separately. So 2x squared plus 6x, they share common factors of 2x. When I do that, I'm left with x plus 3 in parentheses. So 2x times x plus 3 is what equals 2x squared plus 6x. What's very odd, and everyone pay attention, is if you have a negative number right here, if this is ever negative, when you go to factor it, you have to factor out a negative. So the common factor for the right-hand side would be a negative 7. Negative 7 times x is negative 7x, and then this would have to be a plus 3 in order to get the negative 21. Negative 7 times 3 is negative 21. If you factored out a positive number, then you wouldn't get the same answer as x plus 3 and x plus 3, and you need that in order to factor it completely. Once you have this thing right here, this 2x times x plus 3 minus 7 times x plus 3, you need to understand what's happening here. 2x and negative 7 are both being multiplied by x plus 3. Because of that, in math, you can move things around, and you can put 2x minus 7 in its own separate set of parentheses, all being multiplied by x plus 3 like that. And then this would be the final answer for the factored form of the 2x squared minus x minus 21. Now, let me just show you what's happening when I go to factor this. So if I was to do the opposite, if I gave you this problem here and I said simplify this and put it in standard form, you would use the foiling method and you would multiply 2x times x and get 2x squared, 2x times 3 and get 6x, negative 7 times x and get negative 7x, negative 7 times 3 and get negative 21. Now look at what we just did here. When I go to multiply it out, I can see exactly what I found in the very beginning. I was looking for those two terms that when you add them together, they equal this thing. So that's where the process is coming from. The process is basically like discovering what the terms were before they were simplified. And it's definitely a difficult process. I get it. The first thing you should always do when you have these problems is look for a GCF. So in this problem here, which is just randomly letter E, 3x squared minus 16x minus 12. There are no common factors, so I can't take like a factor of 3 out of everything or anything like that. So I have to deal with it and do this long process again. So what you do is you multiply the A number times the C number. So this is going to be A times C is equal to negative 36. That's the factors I need to multiply. And I need those factors to add to be negative 16. That's the middle number. So then I would list those factors of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. I know that in order to multiply to be a negative number, one has to be positive, one has to be negative. So I'm looking for the two factors that if one was negative and one was positive, they would add together to be negative 16. So they basically have to be 16 away from each other. So 1 and 36 are too far away, 2 and 18 are the lucky pairs. I need to get a negative 16 through addition from adding 2 plus 18 with one of them being negative. So it's either going to be negative 2 or negative 18. Because I need it to be a negative 16 and not a positive 16, I know that the 18 would be my negative number. So what that means is I need a positive 2x and a negative 18x. And I'm going to take the middle term here, this negative 16x, and rewrite it as 2x minus 18x. So this is going to turn into 3x squared minus, or doesn't matter in any order, plus 2x minus 18x, and then minus 12. So what I did there was I discovered what those two numbers were before they were added together to become the negative 16x. Once I do that, then I split it down the middle and I factor it by grouping. I can take a 3, or no, sorry, I can't. I can take out just an x from this left-hand side. When I do that, I'm left with 3x plus 2. And then on the right-hand side, like I said before, when you go to factor these, you have to factor them by taking out a negative number. So you can't take out like a positive or you won't get the same thing. So if you're looking at this one, the biggest number you can take out from the 18 and the 12 is a 6. So I'm going to take out a negative 6 from both of these. And I'm left with 3x, since negative 6 times 3x is negative 18. And then plus 2, since negative 6 times 2 is negative 12. So I have a 3x plus 2 here and a 3x plus 2 here, which means I can rewrite this as x minus 6 all times 3x plus 2. Or vice versa, you can switch it around and write 3x plus 2 all times x minus 6. Okay, and then the last thing for today is example 3. Factoring completely basically means you need to take this and you probably can take some GCFs out first. So if I'm looking at this first problem, 6, 27, 15, thinking of a number that goes into all would be 3, and then x to the third, x squared, and x to the first, I can take an x out as well. So the first thing I'm going to do to make this a little bit simpler is take out a 3 and an x from each one of the terms. When I do that, I'll be left with 2x squared plus 9x minus 5. Okay, Okay, so I took a factor out of 3x from each one of the terms. Yep. And now I'm going to continue factoring it. Factoring completely means you should try now to factor this trinomial. This trinomial is going to take the long way because this number here is not 1. So what I have to do is multiply a times c. 2 times negative 5 is negative 10. We need to find the factors of negative 10 that add to be 9. So the factors of 10, 1 and 10, 2 and 5. In order to get a negative number, when multiplying, I know one has to be positive, one has to be negative. So 1 and 10 are 9 away from each other. So in order to get a positive 9, this would have to be a negative 1 and a positive 10. What that means is I'm going to split up the middle term here, this 9x, and it's going to turn into minus 1x in any order. You could do plus 10x minus 1x or minus 1x plus 10x minus 5. Now, it's up to you right now if you want to do the side work first and then put the answer in all together. It really depends. I don't want you to ever forget that this 3x was still here, but right now we're just factoring this part. But the 3x has to be in your final answer. So now what we're doing is factoring this down separately. So this is going to be a line here. 2x squared minus x, I can take out a factor of x from each thing. And sometimes this 3x does get a little bit confusing. So you might want to just forget about it and just come back to it. I'm going to take a factor of x out of each thing. And I'm left with 2x minus 1. And then over here, I can take a factor of 5. And I'm left with 2x minus 1. So this thing right here, just this 4-term polynomial, will factor to be x plus 5 times 2x minus 1. Don't ever forget you already took this 3x out of the very beginning, so that has to be in your final answer. The final answer, factored completely, would be 3x times x plus 5 times 2x minus 1. One way to tell that you have completely factored it is by looking at each separate factored term. You should never see any common numbers inside of these. For example, x plus 5 doesn't have any common factors. 2x minus 1 doesn't have any common factors. But if you ever saw something like this, x plus 1 times 2x minus 4, this would not be considered factored completely, because if you look here at this 2x minus 4, you could take a factor of 2 out of both of those terms, which would mean that this is not factored completely. To factor this completely, you would take out a factor of 2 here on the very front. And when you take a factor of 2 out, this would just turn into an x. And take a factor of 2 out of the 4, this would turn into a 2. Then you would see that this is factored completely.